This spreadsheet is going to allow us to find the relationship between how far a spring is stretched and the force that is on the spring. Now don't forget that you can click on the link in the description for this video and you can have access to this actual spreadsheet yourselves and practice it yourself. So here's what we're going to do. This is a force sensor and it has been zeroed out with the weight of the spring on there. So with the weight of the spring on there, it says the force is 0 at time 0. And then we have a sonic ranger. It sends sound, bounces off of your hand and comes back. Knowing the time it took the sound to go there and back, it measures how far your hand is away. So this is also going to measure its measurements 50 times a second. So both of these are going to measure in 0.02 second intervals, 2/100ths of a second. It will take new measurements. Now the sonic ranger here is only measuring how far my hand is from the sonic ranger. It's not measuring directly how far we have stretched the spring or displaced the spring. So if we know what it initially was, and it was 0.7 or 0.972 meters away initially, and then every second it's getting to be different measurements because my hand is getting closer, we can find out how far we displaced the spring just by taking our initial length minus every subsequent length, and the difference is how far it was displaced. So that's what I'm going to do here. This is 0.972 was my initial, and we're going to subtract it from that one and hit enter. The cells turn green because I've formatted it in the background to let you know that you're on the right track. But if I take that cell and copy it down one, it will be taking 0.972 minus the number down one. So we'll put the cursor on the corner there, copy it all the way down. So 2 seconds, 3 seconds have gone by, 4, 5. I think I did it in 7.5 seconds altogether. So we're going to copy it down to 7.5 seconds. And after 7.5 seconds, we have stretched the spring 0.760 meters in length. While I'm down here, I'm going to go ahead and select this cell and that cell and drag it all the way up like this, because we're going to graph the displacement on the x-axis and the force on the y-axis. So I don't have my options here, so I have to use a little down arrow key there. And I'm going to insert a chart. And it thought we were going to do a line chart. We always want to do a scatter plot. And there we go. Okay. But boy, there looks like a nice relationship here. There is a lot of data points there. And over 300 some data points. And they do fall nicely in a line. So it looks like the relationship is a linear relationship. So I'm just going to move that chart out of the way here. And graphing displacement and force, the relationship is linear. So I'm just going to hit enter and we are good. Now what we want to do is go ahead and find the slope. I'm going to say equals slope open parentheses. Now, it's kind of a pain to copy these all the way down, but we do the y values first, then the x-axis, then the x values. But when I copied it down, I remember that the last cell was 384. So what I'm going to do is I'm going to do the y values, which is D9, and you say colon D384. So that's the whole range of the x values and the y values. And then I'm going to hit comma, and I can just actually, let's just do this. Let's do C9 colon C384. And I'm going to close parentheses. So you can see it, just remembering that last that row there really simplified the time it took to drag things down. So I want to find the slope. And the slope is 6.8 0.8677, and what are the units of that slope? Well, slope is rise over run. The y value was newtons, so we're going to say newtons per, and the x-axis was meters, so it's newtons per meter. Okay, so what does that mean? Well, if I were to stretch that spring 1 whole meter, the spring would have provided a force of 6.8677 newtons. Okay, or if I had stretched it half as far, it would have provided half as much force. So my question now is, how much force would it take to stretch the spring 0.85 meters? I can type it in as a formula. The distance was 0.85. This is how much it would stretch per 1 meter, but we're only stretching at 0.85 meters. So I'm going to just multiply those two, and that's how much force it would have taken, a little less than what it was if we had done it 1 full meter. I guess I should show you the data down here real quick, but this was the position of my hand. I was moving my hand down, 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 down. I tried to keep my hand going at a constant velocity, did fairly good. And as I went down over the course of time, the force went up over the course of time. But anyway, that is what's known as Hooke's law, which is the relationship between displacement of a spring and the force on the spring. My next video will have a discussion of and examples of implications or applications of Hooke's law.